before they release it, I'm not going to trust any of the features that they've said that they're going to release. I've been bitten by this before. They say they're going to build some amazing features, and they pull them out of the language at the last minute. I have an example of that later on as well. So while we are going to touch on some C# 13 feature, I can't promise that they're actually going to make it to the language. Which is why we're going to go back and talk a little bit about highlights from C# 8 first. And the reason I want to do this is because there are some changes in C# 8 that are improved upon in newer versions as well. And they tend to do this with every version of C#. They introduce a feature that's either new or it builds on an older one to improve that functionality. Some of the features in C# 8 are less important than others. Like default interface methods, I rarely use that, but that required a runtime change. What I do use, though, is switch expressions, which is a way for us to define patterns and use pattern matching. Have a lot of examples of this in just a moment. They introduced a further less useful features, or some that are important in different situations, but one that's really important is nullable reference types. Again, this changes how the compiler looks at our code. Not only does it change how we build our applications, but we can avoid having some really nasty problems. The third and final important feature, in my opinion, is asynchronous streams. Asynchronous programming was first introduced in C# 5, so many versions and many years after that, they still improve upon this language feature to introduce concepts like streaming data, using for each loops to subscribe to messages arriving into the application asynchronously, which is quite amazing. And then there's a lot more features. Like being the 8th iteration of the language, there's quite a lot of features here. And there's quite hard to digest all of this. So we're going to spend some time talking about a couple of important features here, and then build upon that using C# 9, 10, 11, and 12 as well. So I'd like to spend some time talking about the nullable reference types, which is probably the second most important thing next to pattern matching. Nullable reference types is really just a way to tell the compiler that you're now going to look at all my reference types a little bit differently. Without assuming that things can be set to null, the compiler will look at my reference types and assume they will always be set to an instance. And if you try to set something to null, the compiler is going to smack you on the fingers, unless you explicitly say that you're allowing this to be null. Now, I mean, most of us have probably run into this issue before. Anyone in here never seen this before? You're either lying, or it's your first week as a developer, and I welcome you to this amazing world. You're going to see this in a couple of weeks. So this here is problematic, and nullable reference or null reference exceptions is probably one of the most expensive problems ever introduced. So I'm going to jump over to Visual Studio. I have a solution here, or project. This is a file new project for .NET 8, could have been .NET 9 as well. But there's one important change here. From .NET 6 and onwards, there's this attribute or this setting saying we want to enable nullable. And this is by default on all new projects in .NET. What this means is that the compiler will now look at all my reference types differently. So if I open a file in this project, if I code incorrectly, which I sometimes tend to do, I'm going to get some warnings. And how many of you in here open this warnings tab and attend to all your warnings all the time? Oh my God, so many liars. There's a fix for this so that we actually attend to them. We can treat them as errors, and the compiler will fail. At least a handful of you are actually looking at your warnings, which is great. And this language feature will now warn me that this class has 2 publicly exposed properties, and it cannot deem that I've set these to a valid instance. What the compiler is actually doing is that it's assuming that string is now not supposed to be null, and there's nothing in this class that dictates that I've set it to a value. So the compiler has no clue or cannot promise that I've set it to a value. I could mark it as optional, or usually say that this is a nullable reference type, just like we've done with value types before. And this could be with any reference type, really, with any class. It doesn't have to be a string. So now with the question mark here, I've moved this warning to whoever's consuming last name. If they access properties on the string without null checking, they will get a warning. As an example, if I scroll up, I'm actually doing that up here. So now I have a warning up here that's saying, you should probably null check this because I cannot promise that this won't throw a null reference exception, which is quite amazing. That was the state of all of this in C# 8. But then there's a couple of things here that's annoying, because I don't really want to change the contract of this class. The way to get rid of this warning would have been to introduce a constructor to move that responsibility of setting this to a value to the constructor. We can now see here that you should probably set first name to a value. That would require that I take this as a parameter and then set this property to that. Now, the problem here is that I've now changed how I create an instance of this. Every consumer of this class now will have to update this, which is quite annoying in my opinion, because that would require a lot of work if I'm using object initializers all over my project, or even JSON deserializing. That would be a little bit tricky. So instead, in C#11, it took a couple of versions, but they improved upon this and introduced another keyword, which is required. So I can now say that, well, I'm going to require whoever creates an instance of this, be it you do that through a object initializer or JSON deserialization, that deserialization or that object initialization has to set this to a value. Otherwise, there's going to be, well, you can't do it with an object initializer, and the JSON deserializer should throw an exception. So it wasn't up until C#11, which is last year or 2 years ago, where this feature got a little bit more complete. So now I'm going to be required to set this to an instance. There's also a thing called init only instead of using set, which means that once I've set this to a value in an object initializer, I can no longer change the value. It's immutable after that, which is good if we're working in multi-threaded environments or using async and await and changing things from different threads. I'm going to set the same required keyword to this other class, and we'll see how this is going to be used in just a moment. Now, because the null reference exceptions were probably not happening in this class, they were probably happening somewhere else. And if I scroll up here again and show you this code piece, what I could do is that I could say, well, I know that this has been deserialized. Let's just assume that I had some code on the lines above that deserialized this from a text file, and I know that this has been set to an instance. I can tell the compiler that, damn it, I know better, and there's no more warning. The problem here is that I very rarely know better than the compiler, so we probably shouldn't do that. This is not called the dammit operator, it's the null forgiving operator. What I can do, though, is either use null conditional, or I can introduce a null check. So the compiler introduces a concept called null state static analysis to keep track of if I've performed a null check or not. So I could say that if person.details.lastname is null, I want to continue and do something else, or continue to the next one in the iterator, and then the warning disappears. So now I've introduced a null check, and the compiler knows that I've done this. Doesn't have to rely on an if statement. This could also be, for example, passing this into an argument null exception, throw if null, and then take person.details.lastname. And it would now be smart enough to know that if I pass something into this method that's null, this method is decorated with an attribute saying that if this was null, I'm going to throw an exception, meaning we will never reach this line if this was null. So the compiler is trying to be super clever and rely on attributes set on different methods and helpers in both .NET and in your code as well. So that's good. What's interesting here is that this will now let me find potential problems in the code much faster. But back with C#8, this feature wasn't really felt complete. We had to do a lot of workarounds to get this work nicely and get rid of those warnings and actually find these problems. And of course, I have a method down here at the bottom as well where I say that I return null, and I shouldn't, because this method indicates that this is going to return an iNumerable, which is a reference type, and without specifying a question mark, it's allowed to be null. If I were to specify a question mark here and say that this is optional, the warning would go somewhere else. And of course, I can tell the compiler that, damn it, I know better. I promise that this isn't null, and then that's problematic. The warning disappears, but someone's going to have a headache. Instead, it would be much better to just return something. And this is nice using a yield here, so I don't have to create a new temporary list. So do yield return if I just have to return one value. And now I'm going to introduce a new feature from C#9 called the target type new expression. So I could say yield return new thing. What this will do is it will look at whatever this is and figure out exactly what instance I want to create and which type I want to create. So that here will now be a new person. It gives me an error here because I have a required property. The details is required. I have to set that. Remember the C#11 feature? So details can also be set to a new thing. And then I also have to set the first name to something as well, and that's also required. So that's really nice. So what happens here is now that if I have one place in my application where I forgot to set that to an instance, and that would eventually lead to a null reference exception, adding these keywords and enabling this language feature will then let me know where that could potentially be a problem. So the nullable reference types, even though they try to solve this quite annoying problem, they won't magically just solve all of it for you. You have to do some manual work as well. And one tip I do have is to enable this thing called treat warnings as errors. I tell people to do this right before they go on holiday, and then check in your code, and let someone else fix all the compiler warnings and errors. Then you're probably not going to have a job to come back to, but at least it was a little bit fun. Now, I probably don't do that, but starting a new project, this is really interesting to turn on, because it will actually tell you immediately that you have something that you should attend to. And either you ignore warnings by using attributes in C# to ignore that warning, or you actually fix the potential null reference exception. If you haven't enabled this, and you run into a null reference exception, I would encourage you to then afterwards enable it and try to backtrack if you could have found this with that null reference exception. Because that will tell you if this was a valuable refactoring or valuable work to do. All right, so the next feature of C# 8 was asynchronous streams. We're not going to spend a lot of time talking about this, but I do want to highlight how you use this. This is a new way of using the for each loop. You append the await keyword in front of it, which indicates that each element that comes into the for each loop will be retrieved asynchronously. So imagine that get elements, that's simply setting up let's say a stream to a message bus in Azure, or reading from a file on disk, and it reads each line or whatever, or it gets a message passed into it from Azure. You will enter the for each loop as soon as there's a message added to the Azure message bus. That will then trigger and run this for each loop for you, or the body of it, as it waits for the next message to be added. So essentially, you can use this to stream data into a for each loop in a very nice and concise manner. But without understanding how async and await works, this can get really tricky, and you can run into some problems with multi-threading and async and await and get some interesting overhead. So even though this looks very simple, as with any language feature, if you don't really understand the impact of introducing that, you could run into problems. With that being said, let's talk a little bit more about C# 9. While we did take a look at some of the features that are introduced, like init only and the target type new expression, there's other things, like record types, which changes how we create reference types, classes, a more concise syntax that gives us a lot of bang for the buck. And we're going to look at an example of this as well. C# 9 gave us the init only setters. Top-level statements is the new way of building your applications. So whenever you do file new project, the program.cs file is going to look extremely minimal compared to what it did 10 years ago. And this is because there's no reason to have the public static void main stuff just right in your face. It's better that the compiler takes care of this for you. What this then enabled is something called minimal APIs, which is an ASP.NET Core way of, in ASP.NET Core, you build applications in your program.cs file to set up really minimal applications. To say that C# 9 only got a couple of enhancements to pattern matching is quite an understatement. They introduced a lot of patterns that built upon the switch expressions introduced in C# 8. And we're going to spend the next moment talking about that as well. There's a target type new expression, and then there's a whole lot of different things that cater for high performance, cater for very specific edge cases, I would say. So what I say here, that there are a lot of features on this list here, but the most important one is probably records and the top-level statements and the pattern matching enhancements. So there's a lot in C# 9 as well, like being the 9th iteration of the language. There's a lot here to digest. And we're going to spend the next moment talking about the pattern matching and record types. Like, pattern matching is not really a new concept. This has been around for a long time for other programming languages like Kotlin, Swift, and Java, and whatnot. They've all had pattern matching for quite a while. So C# is kind of a little bit behind here, or we're behind here at this point. So what pattern matching allows us to do is essentially look at what is the contents of an object. What does this thing look like? I have a puzzle piece here. Is it a corner piece? Is it an edible fruit? Is it something of a certain, is it an apple, an orange? Is it green, yellow, or whatnot? That sounds quite simple, but we can use pattern matching for a whole lot of different things. For example, I could also say, I received this response from the database. Was it successful or was it a failure? Was it a user? Was it an admin? We can do a whole lot of different things with these different patterns. And surely enough, it's really just matching on a type and an attribute. And we have been able to do this since C#1, where you can say, give me the type of the object, compare that to what I'm looking for, and then look at a property value, and then we have to typecast this to use it inside a different context. Looks okay, like all of us probably have code that looks like this and works like this, and it's nothing wrong with this. I will say this, with every language feature in C#, you don't have to jump on the newest thing just because it's released in language. Use it where it makes sense. If this works, then by all means, don't go back and refactor your code to use this instead. Now, if you ask me as a consultant, you should hire me to refactor all your code. I'm just kidding. In C#7, they improved this a little bit, or rather, they introduced the compiler feature of looking at this as a pattern instead. So I can pass the instance into a switch statement and then write cases here for different things that I'm looking for. I no longer have to cast it to the type that I'm looking for. I've ensured that it's an apple, it's an instance of an apple, that's now declared in a variable. But honestly, by C#7, I wouldn't write this code because there's a lot more of it. But this was just to initiate this work of introducing patterns and pattern matching in the language. And of course, we can have a default as well, since it's a switch expression, or a switch. Now, in C#8, they swapped this around, because they've done all the work in C#7 to introduce this. And now we have something called a switch expression, which looks very different to a normal switch, looks very different from an if statement. But basically, we are saying here that I'd like to get a result. Doesn't matter what that result is. It could be an object, could be a string, could be an integer, whatnot. But the result will be based off what the input is. And with this switch expression, I can now fill this here with patterns for this object. And what I like to do here is that I'd like to fill this with expressions, or rather patterns combined with expressions. So as an example, going back to that very simple fruit analogy here, we can say that I'd like to get a string representation of this instance. So if it's an instance of an apple, return this string. If it's anything else, it could be null, it could be a different fruit or whatever, a totally different object. Then we're going to run that last part. And then this part here on the right-hand side of that expression is what's going to be returned. It doesn't have to be a string again, it could be whatever. Now this looks very simple, but what it's actually allowing us to do is that apple part that validates that it's actually set to an instance of that. And I could capture that and ensure that it's not null, which is great. If I wanted to capture null, I'd probably do like apple nullable, and then that could be null as well. So patterns in C#, there's a whole lot of them. We've seen the most simple one, which is a type pattern. There's one pattern called positional pattern, which allows you to work with a deconstructed object, which is not very common, but it is there. It looks like a tuple pattern. Then you have a property pattern if you want to validate a certain value on a property. You can write patterns for tuples or tuples, however you'd like to pronounce that. There's something called a relational pattern. So assuming that I have a test result, for example, I'd like to check if the test is failed or if it's passed. I'd like to check how many days ago was this. I could say test date is more than 10 days ago or less than 10 days. And I can do that in a very nice syntax. I have a lot of examples of this as well. We can combine a lot of them by using conjunctive and or disjunctive or. We can write patterns for different lists, which was introduced in, I believe, C#11. And we can parenthesize patterns. But if we have to parenthesize our patterns, meaning that we have to group them in different portions, then maybe we are designing our code a little bit incorrectly. So that could be a little bit of a code smell. And of course, there's this negation of saying if the pattern is the opposite. You could, for example, say, if the object is not null, that's a negation for null. And we can combine all of these different patterns together. For example, we can say that we have a type pattern, and we can then check a property, and we then can check something in relation to a different value. So let's jump over to Visual Studio again. And I have a sample of this, but before we look at how we use pattern matching, I do want to show you record types. If you haven't seen these before, this is really just a way to define a class. So really what happens is that this here generates a class. We could write record class as well, but in this case, since the default is a class, we could remove that. Which means that we could also use a record struct. To make it immutable, we can do a read-only record struct. But that's really for some different scenarios. We're going to stick with a record class for now, or just simply a record. This lets us introduce a reference type with two primary properties, or a primary constructor that requires the parameter number of attempts and a test date. These will be added as publicly exposed properties. They will be immutable. They will be used when comparing two instances, so we get value-based equality when creating this here. So if we decompile this, and just like a TV chef, I've already pasted this into SharpLab. It's the exact same code. I have a record called test result, takes two parameters, or has two properties, and this on the right-hand side is everything that's now generated here. So we have an implementation of iEquatable, we have two backing fields, we have a publicly exposed property for that backing field, and if we scroll down, there's an overload, or we are implementing the equality operator. And this is where it gets interesting, because normally reference types, they are using reference-based equality checks. If you have two instances of a class, it's going to compare the references. But what this is doing is that it's overriding equals for the same object. So meaning that it's going to, if we scroll here a little bit, just to show you, it's going to compare the backing field of one of them with the other backing field. So it will in fact be value-based equality, which is tremendously useful. And most of the time when you compare two instances, that's really what you might want. Records also allow us to do inheritance. We can have a body of this class or this record and add more methods, more properties, and whatnot. And we use it similarly to normal class as well, because that's really what's generated. So I have a class here, or this is my top-level statement. This is a program.cs file, super simple. Also using this file scoped namespace in one of the classes. As you might have seen here, we no longer have to indent the entire file into the namespace. This is enough to add at the top. All right, let's now take a look here. So I've created an instance of this record here, and as I said, they're immutable. That means that I cannot now go ahead and say, I'd like to change. I don't want to do a software update. I'd like to change the number of attempts, not to the same value, that doesn't make any sense. But this here doesn't allow me to do that, so how would I then change the value? We can dereference this and say the test is now equal to a test with a certain value. I can say number of attempts is equal to 5, and that will now give me a new instance with that new value. So using this wither here is a really nice way of doing this. All right, so back to pattern matching. That's records. I can undo that just to give you the opportunity to have a look at that. So now I'm calling this method. I know that it returns a failed task, which is a subclass of my record, or a subrecord. But I don't know that up here where I'm consuming this method. So what I like to do is that I'd like to say the outcome of this is going to be equal to result and switch. And now I'd like to write some patterns to say that, well, based on what this result is, what type it is, what property values it has, I'd like to do a couple of different things. And again, I'm going to use a very simple example to say that I'm just going to return a string. So the outcome will just be the string representation, but it could just as well have been a method call and get the result from that, a complex type, whatnot. So I can say that, well, if it's passed, I'd like to just return passed. If it's failed, I'd like to return failed. And then for anything else, this is called a discard. And this will match on nulls. It will match on other subclasses. It will, in this case, match on the base type, if that was what we got here instead. It's the same as doing, for example, I said earlier you can capture the value. So I could capture, for example, passed as a local variable of passed. I could capture that as failed. And I could then use this inside the expression if I wanted to. So I can access the properties on that concrete type. And where I'm going with this is that I can do the same here for the discard. I could say var x, because I'm really not that good at coming up with good names. So now this here is going to be the base type. But it could also match on nulls here, so we have to be quite careful that we're not getting a null value. So this here is really the most simple way of defining our expressions or our pattern matches. And I've now used a type pattern together with a declaration pattern to declare this to a local variable. But what if I also want to say that, well, if it's a passed test, not that thing, if it's a past test and the test date's year was 2020, then you're going to have to retake. Because I know that the tests that year, every student cheated on the test, so they have to retake it. I could also do this. That's a relational pattern, or actually, it's a property pattern, but I could convert this into a relational pattern, saying that it has to be between 2022 and less than or equal to 2023, for example. Now I'm using this relational pattern together with the conjunctive and pattern to say that it has to be these different things. I could also completely remove past here, which means that I don't really care what kind of subclass this is. It just has to be either passed or a failed test. This, using the curly brackets here, says it has to be an instance. So an instance where it has these different values. Now, what happens if I negate this? The code becomes a little bit unreadable, especially if I start adding more things. But the compiler is going to try to be smart enough here to figure out which of my tests are then useless. Because we can never reach this code piece here because we already have a pattern that dictates this here. So be careful when using not. And honestly, don't use it to say that a Boolean is not false or not true, because that doesn't make any sense. What we can also do, we're not limited to use this with the switch expression. I can take my patterns, and I could say, for example, if the test or if the result is, and then followed by a pattern, I can do this as well. And if I want to capture this to a local variable that's available only in my if here, I could say the test. And why is that important in this case? Because now the test here is going to be the concrete type. But it's also interesting because what happens if we completely remove this variable declaration up here at the top and instead use it like this? That's where pattern matching and the declaration pattern, all of this becomes quite nice to work with. But again, as with any other language feature, be careful with how you use this. Try to write code that makes sense. Don't simply write patterns just for the sake of writing them. But in most cases where we use this instead of the traditional approach from C# 1 through 6, this is easier to use when communicating with someone in the team or in the business. Now, I'm not saying that your business owners should sit in GitHub or whatever source control you use and read your code. They probably do. But they're probably not going to give you suggestions on how to improve the patterns, even though it makes it easier to communicate the intent here. So a lot of this has been improved upon in C# 9, 10, and 11, and there's a couple of more patterns from C# 11 that I'd like to show you as well. There's something called a list pattern, or list patterns, because we have different ways of working with a collection of data. So in this case here, I've set up a payload of data, and I'm using a byte array here, primarily because it makes me look like a hacker. I'm not, though. So I have this payload, could be a string, could be objects, could be whatever. And basically what I'm doing here is saying that, well, if the payload is an instance of a collection, and the first element matches this, and I don't care about what the rest of that collection is, we're going to enter this if statement. That's a list pattern. And we could write patterns to check if it simply just has a value. I don't care if it's null or not. It just has to have that particular value. And I could write patterns like this for different parts of it as well. If I'd like to say that, well, it has to start with that value, don't care about the second one, and give me a slice of the last portion. This will then slice off the last elements in this collection, or actually it will skip the first two and give me the rest. That's called a slice pattern. And then finally, we have something called a span pattern. So if you're ever working with the really memory efficient span of t or read-only span of t, I can say here that I have my name here as a span of characters, and I can write a pattern that uses a simple string. And this is called a span pattern. So again, they introduce new patterns to allow us to work with this language feature that they introduced in an older version. Even back in C# 7, they introduced the fundamentals of this, but keep improving upon it. And that's kind of a common theme for the compiler team. All right. So let's switch gears and talk a little bit about C# 10. C# 10 improved upon the way that we work with records by introducing record structs. They're a little bit different from record classes. Record structs are not immutable by default. So you have to add that read-only keyword in front of a record struct if you'd like to make it read-only. There's some more things in C# 10, like global using directives. There's file scope namespaces, declarations that I showed you as well. They've made improvement to the property pattern, so if you have nested properties and you access them in a pattern, it will perform a null check for each of them, which is very nice. Doing that previously was a little bit tedious and not very good looking. And honestly, there's a lot more things happening in C# 10, but none of these are really as groundbreaking as introducing pattern matching or async and await. This is the LTS version for .NET 6. And they just focused on improving things and making some caterings for the minimal APIs, like file scope namespaces and global using directives. That's to make it easier to work with that language feature. What is useful, though, is one of them is to improve Lambda expressions. And what they did here was, in C# 9, you had to explicitly declare exactly which delegate type that you were referencing, which is a little bit odd, because if I look at this here, like, I'm not saying I'm smarter than the compiler, but I can clearly see that I take a number as an input and I return an integer. So why wouldn't the compiler be able to do the same thing? Well, someone else thought of this as well at the compiler team, and surely enough, we can now infer the delegate type, which is nice. This means a couple of less characters. And building upon the idea of improving the minimal APIs, they also now allow attributes in lambdas. While we were able to do the same thing without using an attribute or an input to this anonymous method, having attributes in lambdas builds upon minimal APIs and make that concept a lot more complete. And this here, and a couple of more lines, is all that it takes nowadays to build an API or build a website using ASP.NET Core. And this is powered because we can do this because it's powered by that top-level statements, the global using directives, and the implicit usings and all of that. So I'm not going to spend more time talking about C# 10. We're going to spend a little bit more time talking about C# 11 instead, where we introduced the list patterns, slice patterns, and span patterns. We already looked at them when introducing pattern matching, and again, improving upon already existing features. And they're going to continue to do this in new versions of C# as well. C# 11 also introduced a couple of other things, like nameoff, a parameter, and caching delegates for static method groups. Caching delegates for the static method groups is just a performance improvement. But again, working on stability and performance and doing small tweaks in the language can have a huge impact. And then making sure that that doesn't break things is probably quite tricky. In C# 11, they introduced a required property, so it took a little while. Like C# 8 introduced nullable reference types, and this is 3 versions after. So it's taken a little while to get to the state where it feels like the nullable reference types is something that we could all very much use in any type of application. There's a concept of raw string literals, static abstract members and interfaces. There's a UTF-8 string literal, so I can now have UTF-8 strings if I'd like to in my application. There's generic math support, generic attributes, which I honestly don't know why they didn't introduce this earlier. Like, even back in the day when I did, I believe, like ASP.NET web forms, I wanted to build things where I used a generic attribute, and I just couldn't. Then, C# 11 had an interesting feature called parameter null checking, which was unfortunately withdrawn from the language. This is the first time where they've removed a language feature that both upset a lot of people and also made a lot of people very happy. So parameter null checking, I'm going to show you this, even though this feature will probably never see the light of day again. We're going to go back to one of the samples here. Instead of having to null check this portion here, they wanted to do double bangs, and what this would do, it would automatically introduce a null check, and if it was null, it would throw an exception. Surely enough, we would then end up having less null checks in the application, and that would be great. The problem, though, is that it kind of clutters the code base, and by C# 15, it's going to look like this, which is not very nice. So, after a lot of community backlash, they removed that language feature, and that's fine, right? But the problem was that the teams at Microsoft, they all used preview versions of the compiler. All the teams went into their GitHub repositories and refactored to use this language feature. So when they pulled it from the language, they had to go back and revert all their changes. Which is why I never use preview versions of the compiler anymore, because I don't trust that until it's released, like the day after release, then I'm fine using all the newest features. So we saw the list patterns. This is a really nice way of using. I have a collection here where I can then look at this and say, if the first name in this list is Filip and the last one is my youngest daughter, give me all of the names in between, and then I can use this as a variable inside my expression. I don't care about the first one, but if the second one is Sophie and it has some following elements, it's going to match the second one. If it's empty, or just give me all of the other ones if it doesn't match any of that. Or at the bottom, we can say if it's not an instance of a collection. So a lot of things happening here. It's both slicing off data, it's looking at the contents of this as well. We can have this concept of a raw string literal, so 3 double quotes will allow us to paste XML, JSON, and persist the white space characters. We can even use this with string interpolation, like I've done here, to interpolate that connection string into this. If we do this in Visual Studio, I believe it's the same in VS Code as well, and maybe in Writer, we get syntax highlighting for whatever we have inside our raw string literals. So if we have a JSON document or XML and we want to have that inside our code, this is a very nice way of doing it. Now, we also have this UTF-8 string literal. So why is this an important language feature? Traditionally, everything in .NET is UTF-16. And everything on the web is UTF-8, meaning that when we get data into our applications, everything has to be converted into UTF-16. That takes a couple of CPU cycles to do that. It takes extra allocations, and it puts a little bit more stress on the garbage collector. In normal applications, it doesn't matter much, but in really scaled and high-performance applications, it has a huge impact. So therefore, I can now declare that I have a UTF-8 string here. It's a byte array in memory. And then I've also introduced the concept of ranges and slicing off data using the spans here. And this here is an example of writing totally allocation-free code. I'm slicing off my first name and last name into 2 different pointers, so to say. So I have 2 different spans, one pointing to my first name and one pointing to the second. They're not copying any memory. They're not doing a lot of excessive allocations. This puts less stress on the garbage collector. It reduces the amount of allocations. Surely, I have 2 additional, or actually 3 additional things that are references on my stack, but that allocation is like minimal in comparison to copying memory over to a totally new array. And next week, I have a new course coming out on Pluralsight where I talk about benchmarking in C# and profiling in C#, where I use this as an example compared to the traditional approach of using substring and all of that, or even using link, and it's a huge difference. And while this may clutter the code a little bit, this is making a huge difference. All right, so in C#11, we also got the support for static abstract members and interfaces. So there's a problem. If I have a static member in my interface and in my class then implements this, it doesn't tell me that I have to implement that static member, but if I now mark it as abstract, I'm going to get a compiler error saying that it doesn't implement this. So we should probably go ahead and do that. So while C#11 introduced a whole lot of features, we're now at C#12, which is the current version of C#. It was released in November last year. And there are a couple of things that are really important in this release. One of them is the support for primary constructors. They took the concept from the record types and applied that to normal classes, but made it different so that it's going to confuse everyone. And we're going to look at why this is a little bit confusing soon. They introduced collection expressions and the spread element. The spread element was previously referred to the spread operator, but that has since been changed. So if you've heard about this or seen it before, spread operator was previously used to talk about this language feature. There's a concept of interceptors, optional parameters in lambdas. There's alias anytype, inline arrays, ref read-only parameters, and finally, my favorite language feature is experimental attribute. It's the opposite to the obsolete attribute, where you would say that this here is no longer going to be supported. This here is instead saying this code is experimental, and you should be careful using this. Although it annoys my team that I put this on all my code. Which you probably shouldn't. But it is experimental, isn't it? Let's take a look at Visual Studio for a final time today. So I have, let's see here. I have an application here where I've introduced the collection expression. This here is a collection expression where I simply indicate a couple of things. Actually, there's a lot happening in here. This looks like it's just creating an instance of a new collection and then adding a couple of values to that. But there's a lot more happening in here. While it does create a new instance of a collection, it also looks at the target type. So I could change the target to a byte array. I could change it to a list of a byte. And then, actually, let's do this. List. There we go. And that would work as well. So it looks at the target, it looks at the content, it figures out what the most appropriate collection would be, and it creates this, in this case, a list of a byte. So again, being a hacker, I'd like to take my payload and my checksum, and I'd like to append that to a result. As you can see here, I have my payload at the start, I have a checksum at the end to validate that this is all intact. Now, this here duplicates all my information, and I don't really want that. It would be better if I could simply indicate that I'd like to spread the first one across the beginning of this collection, and then do the same for the checksum to say that this here is going to be a new collection where I first spread the content of the payload, and then afterwards I spread the content of the checksum. And while you're not limited to use it simply once or twice, you could do this if you wanted to as well. So the spread element is really handy. Of course, this introduces extra allocations. There's more stress on the garbage collector, but that's kind of obvious when using this language feature. Even if you were using spans, which are very memory efficient, it would still have to copy that memory over to a new one. So the collection expression in conjunction with the spread element is super handy. Next, we have the primary constructors. So primary constructors, they look like the primary constructor you have on a record, but the difference here is that notice how I use a lowercase instead of an uppercase like I did on the record. If you remember that, I'd be tremendously impressed. But here, I use a lowercase to indicate that this here is going to be a private member in my class. And it doesn't matter if I do an uppercase here or not. It's just to indicate that it actually is a private. So instead of having a publicly exposed property, when using the primary constructors on a class, that will only generate a backing field, introduce a constructor, and allow you to then set that value in the constructor. If we want to publicly expose this, we have to create our own public property and set it to that value. So you may be wondering what the reason behind this language feature is. Well, probably some of you in here work in MVC or in ASP.NET Core or use view models or whatnot, where you have like a million dependencies that are injected automatically into your class. So in that case, it would be great if we could just add those at one place, instead of manually having to introduce a constructor that takes the parameter that sets it to your private field. That's just a lot of boilerplate code to write. And if you're like me, like I have like probably 50 dependencies for every controller, which is probably a bad assign on my part, but this at least reduces the amount of code quite a lot. And we can access this like any private field in our class. Like access is like this here, wherever I want inside my class. All right. And if you haven't seen this before, this is a way to return multiple values from a method without creating a class. I'm returning a tuple, which was introduced in C#7. Nice way of having multiple return types. Now, finally, in C#12, they introduced the concept of interceptors. I have this class called a logger. I'm going to call logger.log with a string. If I simply step into this here and take a look, it's going to call its internal method, which will throw a new not implemented exception. Running this will show me that, well, this is in fact not throwing an exception. It's saying hello world, which is a little bit odd because I don't have any console write line anywhere. What's actually happening in here is that I've written some code to replace this during compile time. So when my application compiles, this line of code will be replaced. And that's been possible before with IL weaving. We've been able to do this in different ways, using aspect-oriented programming, for example. But now, I can use a concept called interceptors to say that, look at this I have this attribute. In this file, at this line, at this column, you should replace it with this extension method. The method call has to be exactly the same as the one that I'm replacing. And it looks odd, though. I have to point to the direct file, right? I have to point to the exact line. But if I pull down a NuGet package, that could use source generation and code analysis to figure out what to replace. It could generate an interceptor for me, and then by just pulling down a package from NuGet, that could replace some code in my solution, which sounds very dangerous, but it's an opt-in feature. You have to manually enable who can replace code and who can't. So don't be scared of using NuGet. It's totally safe. And if I run this with the debugger, I'll show you here as well that I'm going to try to step into this, and that doesn't work because I added this attribute as well, debugger hidden, which is another funny prank to pull on your coworkers. I'm just giving you ideas on how to get fired. Now, I love this. So I guess the question is, what's the reasoning behind a language feature like this? Well, it can generate code, look at your solution, look at what you're trying to target, which platform. Are you publishing for ahead-of-time compilation for a specific architecture? Then maybe it's better to generate some code that replaces some of your method calls. And they're doing this in ASP.NET Core. So it's a quite nice language feature. I don't think that we're going to see ourselves writing a lot of interceptors, but using pre-built ones from Microsoft or using source generation will allow us to use this. All right, so just to recap this, we looked at the collection expressions, allowing us to easily create collections, spread elements across new collections as well. The primary constructors are really useful for things like controllers, view models, and so forth. But maybe less so important for things like a normal data class. Especially if we look here at the decompile code, I'm not sure if you can see this, but there's just generated a backing field, and there's also a constructor generated and a toString override. So I wouldn't use this for a normal class like this. Now, they also improved the lambdas again. So lambdas have been around for a long time, but still, improving attributes on lambdas. And in this case here, we can now have optional parameters or default lambda parameters. This is useful in minimal APIs. Instead of having to create multiple different overloads, I can now have one where I have optional parameters. We can also alias any type. I could add this at the top of my class to say that dimensions, whenever you refer to this, it's going to be a tuple with these two different fields. Then I don't have to create my separate class. I don't have to create a separate struct. This would just work. Finally, we looked at the interceptors, which then allows us to take this method call and replace it with this extension method. It has to be an extension method. It has to match the signature. You have to know the exact file and the exact line of code when compiling. And again, this is not something that you probably write unless you pull pranks on your coworkers. But it is used inside, for example, ASP.NET Core to improve performance. They have this thing called a request delegate generator, which is specifically used when you're using ahead-of-time compilation to improve performance, to generate code that's more suitable for your particular use case. So with that being said then, this is all there is to C# 12. Now, it's still quite a lot of things added to the language. And with C# 13, the goal has been to further work on stability and introduce things that build upon the language features already existing in the language. They're not really going to introduce any groundbreaking features. Someone's probably sad in here that are thinking about discriminated unions. Not coming yet, I'm sorry. Will probably come by the time I retire. So C# 13 will introduce params collection. So if you look at this code piece here, I could say that I have a params of an IEnumerable of a string as an input to my method. Now, looking at this, would that indicate that I can pass parameters of arrays, or does it mean that I can build up an array of strings without creating the first collection? Well, I can do this both different ways. I could say, for example, that I have my new collection here, where I use collection expressions to create this. I then pass it into process, and that just works. That's what I would assume this would be doing as well. What I can also do is that I can now, instead of creating that collection, call this method and just pass all the different values. I don't have to create that temporary list anymore, or create a new list and pass the values into it. The compiler will do that for me, which is quite handy. We're also going to get a new lock type, a new lock semantic, so there's some improvements as to how it works with locking. Locking in multi-threaded applications is extremely difficult. It's not something that you should take lightly. So to help with this, to avoid using a sync root or the normal object type in your classes to create a lock, you can use this new thing called a system.threading.lock. And that should be a static in your class, but just showing you exactly how you could use this. And this together with the lock, there's some things happening behind the scenes here. There's this new type. There's a whole bunch of reasonings around why this is better than using the traditional approach of a sync route using a static object. They're improving partials, so you can now do partial properties. For example, like you do with classes and methods, we could have a partial property in the class. This is, again, something that you use for source generation. Partial classes and partial methods have been used for code generation for a long time. If you look at the code behind for some of the different types of projects that you could use, they all rely on partials. And now having partial properties also allow us to further expand on this idea. There's a way to now use implicit index access. I don't have an example of this, but essentially it means that when you're initializing a type that has an array on it, you can refer to like the last element of that list without going through the entire indexing of that collection. There's a new escape sequence if you're into that, method groups for natural type improvements, and there's a lot more. And a lot more in terms of features that improve stability, smaller features that let maybe the .NET team do some of their work more efficiently. But there's a lot happening in C#. And I like that they have these types of language versions as well, where they don't introduce like 15 new features and a couple of them are really groundbreaking. So looking at this here, there's going to be a couple of more maybe important features coming in C# 13, but we'll know more about that after November. Honestly, though, we don't have to jump on all of the new features, and as I said in the beginning, it can be a bit daunting when they keep introducing 10 or 15 new features in every version. Coming in from C# and having been out for a while, it can be extremely difficult to keep track. So one of the things they try to work on as well is to make sure that every feature feels like it belongs in C#. Even though they take inspiration from other programming languages, that is a big thing that they work on as well. So you may have heard about this thing called extensions everything. They talked about this at Build, for example, this year, and they talked about it last year as well. And they wanted to allow us to extend every type and everything available in C#. But unfortunately, as they want to work on more performance, improving already existing language features, introducing this, and then also getting support in Visual Studio and other IDEs might take a little bit more time. So that may be coming in C# 14 or 15, who knows. Again, we can keep track of what's happening. If we go onto GitHub and check the language feature status page, we can take a look at exactly what's going to happen with the language. What's coming in C# 14, 15? What are the reasonings behind things like discriminated unions not making it into the language now? There are some water dividers that we can read up on that has a tremendous amount of people involved, even though there's a team at Microsoft working around the clock, basically, figuring out how to improve the language. They also have to take into account all the comments and all the participation from the community. So it's great to take a look at this. And again, it can be a little bit overwhelming. All of the features in C#, they're here to help us write code that's less buggy, that's more performant. And we should really just use new language features if it makes sense. Like if you ask me to come in and refactor your entire code base, I'm going to first ask, like, do you really have a problem, or do you just want to use the new things because it's more appealing to new developers? Surely enough, they take inspiration from other programming languages, and new developers on the market might like to have a Node-like programming experience in C#, but people that have worked in C# for a long time, they still want to feel comfortable with this code base as well. So it's a difficult trade-off. But using all of the language features in the way that they're meant to is probably more important than just jumping on the next big thing. So with that being said, if you like to learn more about C#, I have a lot of courses on Pluralsight, everything from all of the language features to more in detail on async, await, asynchronous programming. And next week, I have this course coming up on profiling and benchmarking in C#. And I said this in the beginning as well. If you have any questions, I'm always happy to answer questions on either email, send me a ping on Twitter, grab me in the hallway, just talk to me about C# or .NET in general. There's so much happening with both C# and .NET, and I know it can be a little bit difficult to keep track, and therefore, just send me an email if you have any questions. I really hope you enjoy this, and on the way out, there's a little box where you can put your vote. Put a green vote in the box. if you didn't like this, feel free to skip the line and go grab a coffee. All right. Thank you so much for coming. Enjoy the rest of the conference.